We did the back of the review page. I started with problem number 20 because I really want everybody to not miss this on the test and not leave it blank on the review. You're supposed to describe the difference between the two functions. Notice that the top function is a x plus 1, x minus 2, so this is an x cubed. And the bottom one, there's 1, 2, 3, 4, so this is an x to the 4th. So this is a cubic, and this is a quartic. And basically you want to use these words below to describe the differences. So you would talk about how there's an extra root here at positive 2. You would talk about how the y-intercept here would just be, if this goes to 0, that would be 0 times 1 times negative 2, which would be 0. And here again, 0 times 1 times negative 2 squared, still be 0, anytime times 0, 0. So the y-intercepts would be the same. But the end behavior for a cubic that's positive would look like this. And the end behavior for a quartic that's positive would look like that. So you would use words to describe all these things. So make sure you don't leave this blank on your review or the test. Then we started with problem number 12. What is the real zero of the polynomial? Please use your calculators. Go to your y equals, plug it in, whatever it is, and find out what your zeros are and see what the real zero would be. If you want to, you could do the factors of 24 and tell me all the positive negatives. That's another option as well. But if they're looking for the actual real zero, plug it into your calculator. This is how you do it. You put the x to the third, use your little caret, to the third, scoot to the right, minus 2x cubed, no, minus 2x squared, plus 5x, minus 24. So now that everything's in there, all you have to do is hit graph. Okay, in that picture it's a little tough to see. What all the stuff it is. So you could zoom out, zoom 3, hit enter. You could barely see that one. Anyway, you could, zoom 6. You can also hit your table. And there's one of your zeros right there, positive 3. 3 is a 0. That's the only one I see. Now if you list all your possible zeros, 1 times 24, 2 times 12, 3 times 8, 4 times 6, so you tell me positive negative 1, 2, 3, 4, 6, 8, 12, 24, that would be good too, okay? But if you use the calculator, you can find your zero right away. So here, find the zeros and state the multiplicity. X is equal to negative 3, multiplicity of 3. The multiplicity comes from the exponent, whatever's up here, or degree or power, whatever you call it. Here, x is equal to 5, multiplicity of 2. Again, it comes from the exponent, the degree, the power. Number 14, this is an x cubed. What happened to the graph? Well, it reflected. It shifted to the left once and up twice. So we're going to look at f of x being a negative And if it moves to the left, it's +1, and if it moves up, it's +2. Look for those three things. Number 15, we're going to plug in x minus 2 right here for the square. Make sure you square that, or do whatever's in there. So x times x is x squared, negative 2x, negative 2x, positive 4. There's a 2 in front. So the two 2's, that should be a negative. The two 2's make a negative 4x. The 2 in front makes that a 2x squared minus 8x plus 8. Don't forget the minus 3, so 2x squared minus 8x plus 5. Please do whatever the question asks you to do. Make sure you carry out whatever's in front, distribution or otherwise. Number 16, find the equation and sketch a cubic function with a negative lead coefficient and roots. Negative 2, negative 2, positive 5. You could also do it like this. Now we've got to sketch it. So at negative 2 there's a bounce, positive 5, it goes through. Negative means it's going to start over here. And it'll look like that. Again, you're allowed to use your calculator, so you can plug this in your calculator, see what it looks like. 17, same thing. You can use your calculator to find your x-intercepts. You also know that the dominant term is the first term. That means it's a cube. So it's going to go like this. The y-intercept is where all these are 0, so it's 0, negative 6. Again, you can use your calculator, plug it in. There's that point. You could also do synthetic division. I believe 1 worked for us today. 1 times 1 is 1, that makes 5. 5 times 1 is 5, that makes 6. 1 times 6 is 6, that makes 0. So positive 1 was the solution. Then I think we tried a negative 2. So we dropped the 1. And that makes a negative 2, that's 3. It's negative 6, that's 0. And then the last one right here shows it as x plus 3. So negative 3, and we start here, go down through, up, and that's what it would look like. Use your calculator, put in the calculator, see what it looks like, draw what the calculator has. No one should miss the back page. Use the calculator. Up at the top of number 18, describe the end behavior of the polynomial. It's an x cubed, but it's negative. So if it's an x cubed and negative, it's going to flip. And they want to put it in limit notation. So the limit as x approaches negative infinity, f of x is positive, right here. And over here, the limit as x approaches positive infinity, f of x is negative. Oh, that's a horrible infinity. Sorry. Number 19, same type of problem. Same type of problem. This is x squared, this is x, so it's a negative x cubed. Again, it's going to look like that. We're going to graph it. So there's a negative 1 and a 0. It starts here, it bounces, it goes through, and down. Same thing, they want limit notation. So the limit as x approaches negative infinity, f of x is positive, and the limit as x approaches positive, f of x is negative. And that's the review for today. Use your calculators.